Hello and welcome to my channel. My name is Miss M, and today we'll be learning about standard 5.NBT.2. All right, explain the patterns in the number of zeros of the product when multiplying a number by powers of 10. Explain patterns in the placement of the decimal point when a decimal is multiplied or divided by a power of 10. Use whole number exponents to denote powers of 10. All right, so this is actually one of my favorite things to teach because I get to talk about exponents. All right, so initially, what this actually looked like is 10 cubed or 10 to the power of 3. So, in order to find out what the value is, we would do 10 times 10 times 10. So, an exponent tells you how many times to repeat we call this a base. So here we have 10 times 10. So we do 10 times 10. You know that 10 times 10 is 100. But now we add this extra 10 in. So when you're working with base 10, the best thing that I tell students is that you count how many zeros and you know that 1 times 1 is always going to give itself. So I'm going to do 1 and then I need 3 zeros in my answer. Okay? So now the next thing. Now let's set this up like we would multiply. So I'm gonna do 1,000 times 531. All right, and it's just a whole lot of multiplying in this scenario. So we know that 0 times 1 is 0, and they do that 3 times, and then 1 times 1 is 1. Right. So then we have our placeholder 0. Right. So then we have our placeholder 0. All right, so now that we have our placeholder 0, I never understood when I learned it in school why my teacher used to put a dot in the middle of the 0. I guess that was just because she wanted us to understand that it was placeholding. All right, so now we're going to move on to the 3. 3 times 0 gives us 0, and we got that 3 times, okay? All right, so because 3 times 0, 3 times 0, 3 times 0. Now 3 times 1, that gives us 3. Now you see that our number is greatly increasing. All right, so since we have a third one, we have to do 2 placeholder zeros. Okay, so now 5 times 0 is 0, and do that 3 times. And then we have 5 times 1. So once we get all that together, we have to add. So we got 0 plus 0 plus 0, 0 plus 0 plus 0, another 3 zeros. Then we got 1 plus 0 plus 0. That equals 1. 3 plus 0 is 3, and bring down my 5. All right, so remember, every 3 numbers, there's a comma. So we found out that the answer to this particular problem is 531,000. Okay. All right, so now let's do another one. I'm going to clear the screen so that we have enough space because this can get messy. All right, so now we got 10 squared or 10 to the second power. So that's just initially just 10 times 10. So 10 times 10 gives us 100. So now let's do 100 times 76. All right, so 0 times 6 is 0. 0 times 6 again is 0. 6 times 1 gives us 6. Put our placeholder 0. 7 times 0 gives us 0. 7 times 0 gives us 0. And 7 times 1 gives us 7. All right, so we're going to add this together. So 0 plus 0 gives us 0. 0 plus 0 gives us 0. 6 plus 0 gives us 6. Bring down our 7. Every 3 numbers, comma. So we find that our answer is 7,600 in this particular scenario. All right, so now we got 10 to the fourth power. So that's 10 times 10 times 10 times 10. So 10 times 10 is 100. 10 times 10 is 100. Now multiply 100 times 100. So that's 4 zeros. So 1, 2, 3, 4. Add my 1 in. So that's 10,000. So now I have 10,000 times 2. All right. So 0 times 2 gives us 0, and we do that 3 more times. So 1, 2, 3. And then 2 times 1 gives us 2. So remember, every 3 numbers, put a comma. So we get 20,000 for this particular answer to that problem. If you need to pause the video to see how we got the answer, then please feel free to pause the video. All right, so now let's talk about dividing with base 10. All right, so 10 to the first power. So that's just like saying 10 times 1. Or the unique rule, anything to the power of 1 equals itself. All right, so now let's do, let me do it over here. 81,700 divided by 10. So yes, we have to do some long division. All right, so 10, does 10 go into 8? No. But does 10 go into 81? Yes. We can get at least 8 tens, I'm sorry, out of 81. And we know that 10 times 8 equals 80. 81 minus 80, that's 1. Bring down my 7. Will 10 go into 17? Okay. We know that 10 can go into 17 at least one time. 1 times 10 equals 10. All right, 17 minus 10 equals 7. Okay, now I'm gonna drop my 0. Please excuse my arrows running into each other. So this is 70. All right, can 10 go into 70? Yes, it can. It can go in there 7 times. 7 times 10 equals 70. So that's 0. 70 minus 70. Then I gotta drop this last 0. And 10 going to 0, 0 times. Minus 0 equals 0. So we find that the answer to this particular problem is 8,170. Okay, so now we have 10 to the third power. So let's deal with that. All right, so we already 10 times 10 times 10. 10 times 10 equals 100 times 100 times 10. It will be 1,000. And again, if you count the zeros, they'll tell you how many zeros is going to be in your base 10. And then you know that 1 times 1 is going to give you itself. All right, so I'm going to work it right here. So that's 72,000 divided by 1,000. Will 1,000 go into 7? No. Will 1,000 go into 72? No. What about will 1,000 go into 720? No. What if we said, will 1,000 go into 7,200? Yes, it could. So it could at least go in there 7 times. 7 times 1,000 is 7,000. So now we're going to subtract 0, 0, 2 minus 0 is 2. And 7 minus 7 is 0. All right, so then we drop the last 0. Can 1,000 go into 2,000? Yes. How many times? 2. 2 times 1,000 is 2,000. So now if we subtract 2,000 minus 2,000, we get 0. And we find out that the answer to this particular problem is 72. All right, lastly, we got 2 million divided by 10 to the fourth power. So we got 10 times 10 times 10 times 10. All right, so if I do 10 times 10, we know that that's 100. 10 times 10, that's 100 as well. Now we multiply 100 times 100. Again, you can count how many zeros you have in both of your base 10 numbers and put that many zeros. So there's 4. 1 times 1 is 1. All right, so that's 10,000. All right, so now let's do 10,000, 2 million divided by 10,000. So I'm going to do it on this side. So 2 million divided by 10,000. Will 10,000 go into 2? No. Will 10,000 go into 20? No. Will 10,000 go into 200? No. Will 10,000 go into 2,000? No. Will 10,000 go into 20,000? Yes. So how many times could 10,000 go into 20,000? at least 2 times. All right. So now 10,000 times 2,000, 10,000 times 2, I'm sorry, is 20,000. All right, so we're going to subtract. That's 0. Bring down the last 2 zeros. Well, bring down one of the zeros. How many times 10,000 go into 0? None. So that's 0 minus 0. Uh-oh. Make that 1 0. It's Halloween, so hey, look at it as a ghost. All right, so now drop that 0, last 0. And we know that that's 0 again. And we find out that this answer is 200. All right, so feel free to pause the video to check your answers. And I even did Halloween colors. Happy Halloween. So, in these particular problems, we'll be focusing on 2 word problems dealing with the base 10 standards. All right, so let's start with this one. I like to identify keywords to help me understand what I'm going to do. An internet company offers internet service with a cap of 1,000 gigabytes for $30.06 per month. What is the price per month? All right, so it kind of tells us what we're going to do with the word per. Per can go 2 different ways, but in this particular instance, it's going to go as division. I'm sorry. All right, so what I'm going to do, I need to divide the price per gigabyte. So I need to divide $30.06 divided by 1,000. Put your decimal up here because you already know where your decimal is going to be placed in your answer. Can 1,000 go into 3? No. So that's 0. All right, 0. 3 minus 0 equals 3. Drop your 0. Can 1,000 go into 30? No. So that's another 0. Bring your 0 down. 0 times 1,000 is 0. All right, 30 minus 0 is 30. So now let's drop this next 0. So can 1,000 go into 300? No. So let's say 0 times 1,000. So that's 0. 300 minus 0 is 300. All right, then drop this last 6. Sorry, my line look a little crooked, but it's okay. All right, so now we got this particular scenario. So we got, will 1,000 go into 3,006? Yes, it can go 3 times. So 1,000 times 3 is 3,000. And we could work this 3,006 minus 3,000 is 6. We could keep working this until, it just goes out. It'll just be, you can keep adding the zeros if you want to. 1,000 don't go into 6, 0, da da da. Bring it down, 6. And it'll just keep going until we actually get 6,000. So I'm going to stop right here because with money only has 2 places behind the decimal. So we find that this person is paying 33 cents. I'm sorry, not 30, but 3 cents, because these are our 2 numbers that we focusing on. 3 cents per gigabyte, which is really cheap. Okay. All right. So a round trip from Amy's house to the grocery store is 8.90 miles. Amy estimates since she moved into her house that she has gone 1,000 times. How many miles would that mean Amy has traveled? All right, so let's get some words out of here. We got the word estimates. We got the word times. So we got the word how many. We got so many different words here. All right, so let's focus on our key. So this is my keyword, times. When I see the word times, that let me know I'm going to multiply. So I'm going to do 1,000 times 8.90. All right, so I know I'm going to have 2 decimal places in my answer. So I got 0 times 0 is 0. 0 times 0, so I'm going to do that 2 more times. And 0 times 1 is 0. All right, put my placeholder 0 in play. 9 times 0 is 0. And then 2 more 9 times zeros. And then 9 times 1 is 9. All right, then my 2 placeholder 0. 0 times 8, 0. And then got to do it 2 more times. And then we have 8 times 1, which is 8. So now we got to add. So I'm going to do the separation bars in between so you'll know exactly what's being added up. Okay? So all these zeros added together is going to give us 0. All these zeros is going to give us 0. All those zeros going to give us 0. And all these zeros going to give you 0. Then I got 9 plus 0. That gives me 9. And then I have an 8. Bring it down. So now, remember, there are 2 place values that were in your particular answer. So I need to work 2 place values back in and put my decimal back in. So now I find out that the answer to this problem is 8,900. All right, so if you want to pause the video to kind of look back at these problems, please feel free to. Okay, so again, for this particular problem, what is the product of 3.7 times 10 to the fourth power? All right, so the first thing we want to do is start with this exponent scenario. All right, so essentially, when we're looking at that particular issue, it's like saying 10 times 10 times 10 times 10. So you could do 10 times 10 and 10 times 10 and get 100 times 100. And you do that, you could just put 1, 2, 3, 4 zeros. Every 3 numbers get a comma. So that's one way, or you could have just saw that the 4 tells you how many zeros to put in your base 10. So 1, 2, 3, 4. Then you still would have had 10,000. All right, so now that we ain't got the 10,000 scenario in play, now we're going to go 10,000 times 3.7. So we're going to do 0 times 7, that's 0. Then you got it 1, 2, 3, 3 more times. So I'm just going to go ahead and put it 3 more times. And 7 times 1 is 7. All right, so now I'm going to do my placeholder. So 3 times 0 is 0, and we got to do it 3 more times. All right. And then we have to do 1 times 3, which is 3. All right, so now we add. Okay, 0 plus 0 is 0. All right, 0 plus 0. All right, 7 plus 0 is 7. And then bring down 3. Now we got to focus on this decimal place. So this was 1 place value in. So we need to go 1 place value, put a decimal. So we come out with this particular number. So that's 37,000. So the answer to this particular problem would have been C. So you always got to focus on that decimal place in your answer, because if you forget that decimal place, then you would have thought the answer would have been D. But because we had to incorporate that decimal place back into the problem, that made it 37,000. All right, so now let's focus on this problem. What is the product of 2.5 times 10 to the third power? All right, so you could do 10 times 10 times 10 if you would like, and do 10 times 10 equals 100 times another 10. You could just count the zeros. It tells you, because 1 times 1 is itself. So if you would like to do it that way, then fine. If you want to just do 10 cubed and do the 1 and add 3 zeros, because this 3 tells us how many zeros are in base 10. And this only works in base 10. Please don't try this with no other exponent, because it's not going to work unless you do 1 to the power of whatever. Then it's always going to be 1. But anyways, so let's get started. So now that we know that this 10 cubed equals 1,000, we are going to do 1,000 times 2.5. So 0 times 5 is 0. And then we know we got to do it 2 more times. So I'm just going to put 2 zeros down. And 5 times 1 equals 5. So now let's put our placeholder 0 in. 0 times 2 is 0. And we got to do it 2 other times. And 1 times 2 is 2. So now let's add it. 0 plus 0, 0, 0, 0. 5 plus 0 is 5. 25. All right, so now we got to think about this one decimal place right here. So that one decimal place have to come back into our answer. So I'm going to put it there in between. So now we have 2,500 before the decimal. So our answer to this question is D as in dog.